Now the measurement in our study, which is the volume 2 of physics, which I am going to start. After discussing the matter in the previous topic, previous volume, now is measurement, which has everywhere measurement is required in either shape and size of geometrical figures, which we have gone through our videos in mathematics. It is necessary to maintain the system of measurement universally same. Otherwise, we'll have difficulty to calculate the exact figure. It may also jeopardize the safety of aircraft, also with lot of passengers, crew, and heavy loss of money. There was an example as an accident occurred due to this. It was an history in aviation due to lack of knowledge of universal system of measurement. The aircraft collides on air and there was no fault of ATC. They were said to maintain a certain height before they land, and wrong interpretation about the measurement system did so. There are two types of system, either it is CGS or centimeter, gram and second. Centimeter is for the length, whereas gram is for the weight or mass, and lastly the time, which is measured in seconds. This is called metric system, and the another system is called English system, which is FPS, that means foot, pound and second. Foot means the measurement of length and pounds mean the measurement of weight or mass, and second is the measurement of time. This is called metric system. We are much concerned about these two systems only, because we will not go the history of how the measurement had different units and whatever units in earlier involvement of history till these schemes. US uses English system, that is FPS, and the metric system used in the most European countries, and it has been also adopted by the US Armed Force. The metric system is normally used in all scientific application. We can convert metric system to English system and vice versa and find it equivalent here. Metric system and vice versa, which will be which we will give a chart to do so. Here I am showing a chart. Metric system or SI system. We also say metric system as SI system. In this system, we see there are three measures. The basic quantities which requires unit of measurement are mass, weight, length and time. In order to arrive at values of distance, weight, speed, volume, pressure, etc., it is necessary that we become familiar with the accepted methods for measuring these values and the units used to express them. Though we won't go to the history of measurement as it is the long, so here we are only concerned with the English system, as I have said earlier. Length and distance. The unit of length and distance are the millimeter, centimeter and kilometer. In English system, the foot is equal to 12 inch, the yard is 3 feet and mile is 1760 yard. The distance was later changed to 5280 feet, which is the present statute mile in the US. The nautical mile used to internationally for navigation is based on the 16th of the degree of the Earth's circumference of the equator. It is approximately 6080 feet or 1853.2 1853.2 meter. A speed of 1 nautical miles per hour is called 1 knot. Many other units of length measurements have been used in, not. The basic unit of measurement is the metric system, is the meter, as we discussed. Now, how this meter has come into picture and what is, how we will know this is a meter and what we will discuss now. The length of a meter is based on a distance equal to the 10th million of the distance from the equator to the poles measured along a meridian. The meridian being a shortest distance along the Earth's surface and a right angles to the equator. This distance is equal to 1650763.73. That is 16,50,763.73. Wavelength of the orange red light of excited krypton of mass number 86. Thus we see that the meter is based on sound reference, but that will always be approximately the same. In order to provide an exact reference meter for scientific purposes, a bar of platinum was inscribed with two lines exactly 1 meter apart for the freezing point of water. This is 32 degree Fahrenheit or 0 degree Celsius. The international meter bar is kept at the Bureau of Weights and Measures near Paris. Copies of this bar have been made and are kept in depositories in all the principal nations. In the metric system, all the measurement of length are either multiples or subdivisions of the meter based on multiples of 10. So how we do that? See, 10 millimeters equals to 1 centimeter, 10 centimeters equals to 1 decimeter, 10 decimeter equals to 1 meter, 10 meters equals to 1 decameter, 10 decameters equals to 1 hectometer, 10 hectometers equals to 1 kilometer. So 1 meter we have seen is, now we will conversion we will get to in inches. Such 1 meter is equal to 39.37 inches, which is a little longer than the US yard. Thus 1 decimeter is equal to 3.937 in 1 inch. 1 centimeter is equal to 0.3937 inches, and 1 millimeter equals to 0.03937 inches. In practice, the units of length most commonly used are the millimeter, the centimeter, the meter, and the kilometer. Now for the area. What is area? Area is the measurement of a surface or a land we measure in. We will first know how to measure in English system and then in the MK system or SI system. Measurement of area are usually indicated in units that are square of the unit of length. Hence in the English system the units will be square inch or square foot, the square yard, and the square mile. Another unit of area commonly used for measuring land is acre, which is equal to 43,560 feet square. Area is the metric system is indicated in square metric units. These are the square centimeter, the square meter, and the square kilometer. Land measure is the metric system is indicated by means of the hectare. The hectare is equal to 10,000 meters square or 2.47 acres. Now volume and capacity. Volume and capacity are indicated in three-dimensional units or cubes of the basic linear units. The cubic inch, cubic foot, and cubic yard are the common units of volume in English system. Other units of volume or capacity are the gill, pint, quart, and gallon. In general, when speaking of volume, we use the cubed units. And when speaking of capacity, we use the gill, pint, quart or gallon. The metric system employs the cubed metric units as units of volume. The most commonly expressed units are the cubic centimeter and the cubic meter. For capacity, the liter is generally employed. The liter is equal to 1000 centimeter meter cube. It is equal to 1.056 US liquid quarts. 1 meter cube equals to 1000 liter. Now weight. WEIGST, weight. Units of weight is the English system are no more standardized that offers unit of measure. Among units of weight in common use are grain, troy, ounce, ever, lupus, ounce, troy, pound, abo, lupus, pound, and ton, short ton. The following table shows I will give you the tables. I will make you to know in my words. I'm not giving any chart like that. See how this is. 7,000 grains equals to 1 AVDAP pound. Now 5,760 grains equal to 1 troy pound. 12 troy ounces equal to 1 troy pound. 16 AVDP ounces equal to 1 AVDP pound. Now 2000 AVDP pounds equals to 1 ton, which is salt. The grain is the smallest unit of weight in the English system and was derived from the weight of a grain of wheat. It is used principally for the measurement of medicinal components or drugs. The troy, ounce and pound are used for weighing precious metals such as platinum, gold and silver. Our lupus, which weighs are used for almost all materials and objects in the English speaking countries. These are the common ounces. OZ we write for ounce. Pound, hundredths weight, that is CWT, and ton, which we are most familiar. The most uniform system of weight in the SI metric system, the following shows the relation. The following I will give you. 1000 kilograms, which is in the metric system of weight. 1000 grams equals to 1 kilogram. Now 1000 kilograms equals to 1 metric ton. The gram is the weight of 1 centimeter cube of pure water at a temperature of 4 degrees centigrade or 39.2 degree Fahrenheit, which is the point of greatest density for water. The gram is equal to about 15.432 grains and the kilogram is 2.2046 pounds ABDP. It is readily seen that the metric system of weight is much less complex than the English system because the weight can be converted from one unit to another merely by moving the decimal point to the right or left. For very small measurement of weights, the milligrams is used in the metric system. The milligram is 0.001 gram. Now, the units of measurement, we know that for other things also, such as we can measure force, density, electrical values, light intensity, sound intensity, velocity, energy, and numerous other values. In such section, in this, I will say I'm explaining you to know how most commonly known units of measurement. We will discuss for the physical laws and phenomena to define the units of measurement required in each area. Conversion factor is most important. We can derive one formula to another also, and we can convert one form to another with the relationship. Now, what is gravity? Gravity or gravitation is the universal force that all bodies exert upon one another. It is defined by the universal law of gravitation, which states the attraction between particles of matter is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This can be expressed by the equation capital F equal to capital G, and in the numerator m1 m2, which is in smaller m1 and smaller m2, and then in denominator we write r square, where F equals to attractive force, small r equal to distance between two bodies or particles. M1 and M2 is masses of bodies. G is constant whose value depends upon the value used in the equation. If we express it in dynes, M1 and M2 in grams and R in centimeter, then G is found to have the value of 6.67 into 10 to the power minus 8 or 0.000000667. Weight is the now specific gravity and density. It is to be very much understood about these all things. What is specific gravity and density? It is very much to be understood, because all these things what I am discussing today and before also in physics, these are mostly you will see in the aerodynamics and other volume of mine. So I am taking basic science, and it is very much important throughout your studies of AME course as well as license, as well as whatever you are facing, that as module and other things. And since it is referred by the several books, as I earlier mentioned in all my videos, so go all through the lines by line and memorize it and try to understand, because every word has a question, and same to I say it has answer also. What is specific gravity? The specific gravity of a substance is the ratio of the density of the substance to the density of water. The density of a substance means mass per unit volume. In the SI metric system, the density of substance is expressed in kilograms per cubic meter. The density of water is 1000. Since 1 meter cube of water has a mass of 1000 kg. In the British system, the density is expressed in pounds per cubic foot. For water, the density is therefore 62.4, since 1 feet cube of water weighs 62.4 pounds. To determine the specific gravity of a substance, when the density is known, we merely divide the weight of a given volume of the substance by the weight of an equal volume of water. For example, if we wish to know the specific gravity of lead, and we know that the density in pounds per cubic foot is 708.24 pound, 708.24 pound. We divide 708.24 by 62.4 and obtain 11.35, which is the specific gravity. To find the weight or mass of a given volume of a substance, when the volume is expressed in cubic feet, we multiply the volume in cubic feet by the weight of 1 feet cube of water, and then multiply this product by the specific gravity of the substance. Let us assume that we wish to find the weight of 10 feet cube of copper, and we know that the specific gravity of the copper is 8.9. Then 10 into 62.4 into 8.9, which becomes which you will get as a product as a 5553.6 pound. If the volume of a substance is expressed in cubic centimeters, we can find the weight in grams simply by multiplying the volume by the specific gravity. For example, the weight of 20 centimeter cube of silver is 20 into 10.5, which is equal to 210 grams. The specific gravity and density of solid liquid are expressed as our gases require a different treatment. It is apparent that the weight of a given volume of a gas will depend upon the pressure and the temperature. For this reason, the density of a gas is given according to standard pressure and temperature conditions. That is, pressure is of 676 of mercury and the temperature of 0 degree centigrade. Under these conditions, it is found that the density of dry air is 1.293 gram per liter, or 0.081 pound per feet. Since the density of air is used as a standard, the specific gravity of air is given as 1. The specific gravity of any other gas is the ratio of the mass of a given volume and the gas to an equal volume of dry air, with both the gas and the air being under standard condition. Now we will go for force and motion. What is force and what is motion? How we will describe the force and motion? Now, force may be defined as a push or pull motion upon an object. In the SI metric system, the dyne dyn in short is employed as the unit of force. One dyne is the force required to accelerate a mass of 1 gram 1 centimeter per second. This may also be expressed 1 dyne equals to 1 gram into 1 centimeter divided by second square. The unit of force in the SI metric system is the Newton, the capital N, the sign is. The Newton is the force required to accelerate a mass of 1 kg 1 meter per second square. 1 Newton is equal to 10 to the power 3 dyne. Or 0.225 pound. In British system, the poundal is the unit of force. 1 poundal is the force required to accelerate 1 foot per second square. When we are not relating force to a particular acceleration, we often use the pound to express the value of the force. For example, as we say that a force of 30 pounds is acting upon a hydraulic piston. Force is required to produce motion in a body that was previously at rest, and force is also required to stop the motion of a body. The concept of force and motion are expressed by Newton's law of motion. Newton's first law of motion states a body at rest tends to remain at rest, and a body in motion tends to remain in motion in a straight line unless forced to change its state by an external force. The first law of motion concerns the property of matter called inertia. Inertia is defined as the tendency of matter to remain at rest if all rest of or the continue in motion in a straight line if in motion. Hence, it is seen that Newton's first law of motion defines inertia. The property of inertia is demonstrated by the fact that artificial satellites will continue to orbit around the Earth for months or years, even though they have no means of propulsion. This is because there is no appreciable outside force in space to retard the speed of the satellite. The only substantial force acting on a satellite orbiting the Earth is the force of gravity. Gravity causes the satellite to curve around the Earth instead of shooting off in space. Inertia can also be demonstrated by simple experiment with a glass of water. If a glass of water is placed on a piece of paper of a smooth surface, the paper can be jerked from under the glass without disturbing the glass or its components. The inertia of the glass of water causes it to remain at rest when the paper is moved. Now, what is acceleration? Acceleration. Newton's second law of motion explains acceleration. Acceleration motion may be defined in the change in velocity of a body. If the body increases its velocity, it has positive acceleration, and if it decreases in velocity, the acceleration is negative. The second law of motion states the acceleration of a body is directly proportional to the force causing it and inversely proportional to the mass of the body. This means that a given body will accelerate in proportion to the force applied to it. For example, if a 10 pound in bracket 4.536 kg weight accelerates at 32.2 foot per second square, 19.82 meter per second square is the SI metric system. When a 10 pound in bracket 44.5 Newton force is applied to it, it will accelerate at 64.4 feet per second square. When a 20 pound in bracket 89 Newton force is applied to it. See, I am going line by line of a book, and it will be much you have to understand, much you give you more understanding, and I think you will also refer that book on going through this line, and you will say, just I have copied it, but since this book will give you more information, and no other books I have seen through till I have 2-3 books, and more books are to be referred, but this has got a very good definition of all these things what I am discussing here. If we ignore the action of air acting on a freely falling body, we find that it accelerates at the rate of 32.2 foot per second square. This is called the acceleration of gravity, and it's indicated by a letter symbol small g. From this we know that when a force equal to the weight or mass of a body is applied to the body will accelerate at 32.2 foot per second square. If there is no function or other force opposing the applied force, this knowledge is useful in developing an equation based upon Newton's second law. That is F equal to capital M into acceleration, that is small a, divided by gravity, that is g, small g, where F equals to force, which is measured in pounds, M equal to mass, which is measured in pounds, A equals to acceleration, it is measured in foot per second square, or in SI unit meter per second square. G equals to 32.2 feet per second square, in bracket 9.82 meter per second square. With this formula we know the weight or mass, we can easily determine the force required to produce an acceleration. If we wish to know how much force is required to accelerate a 4,000 pound 18,014 kg automobile to a speed of 60 mph 26.8 meter per second, in 10 seconds we must first determine the rate of acceleration. 60 miles per hour is 88 feet per second, and the automobile is accelerated from 0 to 88 feet per second. Hence, if the automobile is accelerated from 0 to 88 feet per second, in 10 seconds the rate of acceleration is 8.8 feet per second square, or 2.683 meter per second square. Then by the formula we see that F equal to 4000 into 8.8 divided by 32.2, which comes equal to 1093.1 pound, or in SI unit it is 4862 Newton. From the above equation we know that it requires a force, or that is a push, of 1093.1 pound in bracket 4862 Newton, and accelerate the automobile from 0 to 60 mile per hour in 10 seconds. When using SI metrics in units in this formula, a factor of 9.80 must be applied, because 1 kg of force is equal to 9.807 Newton. The answer is F will represent kilograms instead of Newton, unless this is done. Now, action and reaction. What is action and what is reaction? See, action and reaction are explained by Newton's third law. To every action there is an equal and opposite reaction. What does it state? This law indicates that no force can exist with only one body, but the existence of a force requires the presence of two bodies. One body applies the force and the other body receives the force. In other words, one body is acting and the other body is acted upon. This is clear in the operation of an automobile. The wheels of an automobile exert a force against the road, tending a force the road to the rear. Since the road cannot move to the rear, the automobile is forced to move forward. There are numerous examples of action and reaction around us. When we stand on the floor, our body through our feet applies a force to the floor at the same time. The floor is applying the same force to our feet. Other examples of action and reaction are the recoil of a gun, the backward force of a fire hose when the water is turned on, the thrust of a propeller and thrust of a rocket, and the thrust of a jet engine. A rocket engine is jet engine, and the thrust of a propeller or rocket or a gas turbine engine depends upon the acceleration of a mass, that is weight, in accordance with Newton's second law. A propeller accelerates a mass of air, rocket accelerates the gases resulting from the burning of fuel, and a turbine engine accelerates both air and fuel gases. The quantity or mass of air and gases accelerated and the amount of acceleration determine the thrust produced. The basic formula for the thrust of a gas turbine engine is F equal to, means capital F equals to small w, small weight, small g, in bracket capital V2 minus capital V1, where F equals to force pound, which has got its unit pound. Now W, that is small w, that is equal to flow rate of air and fuel gases, and g, small g, which is equal to acceleration of gravity, and bracket I am writing 32.2 foot pound second square, or 9.82 meter per second square. V2 is equal to final velocity of gases, V1 equals to initial velocity of gases. It must be noted that if metric units are used in the above formula, kilograms of force must be converted to newtons. 1 kg is equal to 9.807 Newton. And thrust, what I have discussed about these all things in third action and reaction. This all we will be discussing when we are going for the jet propulsions volume chapters. Now, what is centrifugal and centripetal force? Everyone is familiar with the fact that weight is attached to the end of a cord and twirled around. If we do so, it will produce a force tending to cause the weight to fly outward from the center of the circle. This outward pull is called the centrifugal force. There is an equal and opposite opposite force pulling the weight inward and preventing it from flying outward. This is called centripetal force. From Newton's first law of motion, we know that a body in motion tends to continue in motion in a straight line. Hence, when we cause a body to move in a circular path, a continuous force must be applied to keep the body in the circular path. This is centripetal force. We can use either one or two formulas for determining the magnitude of centrifugal force, depending upon whether we are employing the metric system of the British system, metric system or the British system of measurements. In the metric system, we determine the centripetal force in dynes by the formula F equals to small m small v square by denominator r small. Where capital F equals to force, dyne or Newton, small m equals to mass, which has unit gram or kg, small v equal to speed, which has unit centimeter per second or meter per second, small r equals to radius of circle, which has unit centimeter or meter. The result in dyne is divided by 1 lakh will give the force in Newton. To find the force in pounds, we employ the formula F equals to W capital small v square divided by small g and r, where F equals to force, that is pound, or in bracket Newton, W equals to weight or pound, or in kg, which are their units. Small v equals to speed, which is foot or meter per second. Gram. Gravity. Acceleration of gravity will be 32.2 feet per second or 9.81 meter per second square. Now small r is equals to radius, which is measured in feet or meter. If we discuss to determine the value of the centripetal force required to keep a 10-pound weight in a circle of 20 feet radius while moving at a speed of 60 feet per second feet per second, we proceed as follows. F equals to 10 into 60 square divided by 32.2 into 20, which gives 36,000 divided by 644, which is equal to 55.9 pound. And in bracket we can say it is 248.7 Newton. Now, what is velocity and speed? We often hear the word velocity and speed used in the same sense. That is to indicate how fast something is moving. The two words are similar in some respects, but there is an important difference when we use the word velocity. We include direction, distance, and a straight line from point to point, and the time required to move from one point to another. If an automobile travels from point A to point B in a straight line in 1 hour following the regular path, velocity of the automobiles is 20 miles per hour, northeast. Speed involves only the length of the path traversed by a body or the time required to traverse the path. In this, the average speed of the automobile would be 35 miles per hour because it required 1 hour to travel a distance of 35 miles. Instantaneous speeds and instantaneous velocity may be the same in magnitude, however speed does not include direction. Velocity may be defined as the rate of change of position in relation to time or the rate of motion in a particular direction. From the above we can see that a body may be moving at constant speed, but it may also be accelerating by changing direction. A body moving in a circle is commonly accelerating because it is constantly changing direction. Acceleration is a change of velocity, and a change in direction is also a change of velocity. And another velocity we have to make, we are much familiar, that is an angular velocity. How it is? It is a rate which a body rotates about a fixed axis, and or the angle by which a body is displaced, divided by the time required for the displacement. Angular velocity is expressed in degrees per second or in radians per second. A radian is 360 degree, and the radius of a circle is equal to the circumference divided by 2 pi. Then 1 radian equals to 360 degree divided by 2 pi, which equals to 57.3 degree. Now we have seen this type of things, velocity and speed. This may be classified as an scalar quantities and vector quantity. Here speed is an scalar quantity and velocity is a vector quantity. We have to solve this in coming topic. We are going to discuss what is that composition and resolution of forces. First, what is vector? Vector is a quantity involving both magnitude and direction. A vector is represented by a straight arrow pointing in the direction in which the quantity is acting, and the length of the arrow represents the magnitude of the quantity. For example, if we take an arrow y, which represent a force of 40 pounds acting upward, as would be the case when a man picks up to a 40 pound suitcase. The arrow is marked off in segments, each representing 5 pounds. A force of 10 pounds is acting upward from the point O, and a force of 5 pounds in acting the right from the point. In a vector, we can determine the resultant force or resultant by drawing the parallelogram, that is rectangle of, in the case, OX, AY, and then measuring the diagonal vector OA. OA is the resultant, and by measurement is found. We can use the formula for solving right triangle as follows. OA equals to root under 10 square plus 5 square, that is 11.18. To solve a problem involving a right triangle such as, it is convenient to use basic trigonometric formulas. These formulas are based upon trigonometric functions such as sine, cosine and tangent of a particular angle, as we will explain later on in our coming classes. This is later on in this volume only, that is the values of the function of a right triangle, such as it may be expressed as follows: sine equals to side opposite by hypotenuse, or sine A equals to, if you are taking A as a A is drawn from C to A is perpendicular A by C is a base, and cos A is equal to base upon hypotenuse, that is C. Tan A equals to A upon B. If we find the sine or tangent of the angle OX, or on a table of trigonometric function, we can see that all the angle is about 63 degree 27 minutes. The tangent of the angle is 1/10 by 5 inches, that is equal to 2, which is the tangent of the angle 63 degree 27 minutes, as shown in the tangent table. Hence we know that the direction of OA is 63 degree 27 minutes counterclockwise from OX. We have to draw these figures and try to understand. And if you are going through these books, through this book, you will know to see this by understanding every line by line and going through the books. Earlier I discussed about the rectangle, thereafter I discussed about the right angle triangle. The method of composition of force can be also used to determine the path of a flight of an airplane flying in a crosswind. An airplane, take an example such as an airplane is flying at 150 mile per hour on a heading of 340 degree, and there is a crosswind of 50 mile there is a crosswind of 50 mile per hour blowing from 45 degree. To determine the flight path and the speed made good, we draw a triangle or parallelogram of forces. OB is drawn to convenient scale to represent 150 mile per hour 340 degree clockwise from 0 degree. OA is drawn from 45 degree through the point O and scale to represent 50 mile per hour. Then the parallelogram OACB is drawn and the points O and C connected by the diagonal OC. The diagonal represents the direction and speed of the airplane along its actual flight path. This all may confuse you because I am not giving you the figure. You just imagine you take one point and another point such like that. You will get this as per my word. You will get the real picture. Now it may also be solved by the law of sines or law of cosines, as I earlier explained. From in the video of mathematics, from any one point we can combine any number of force and obtain a resultant. If a force OA has a value of 20 pound, a force OB has a value of 15 pound, that is in bracket 66.7 Newton, and a force OC has a value of 26 pound, which is equal to 115.7 Newton. We can easily determine the resultant force OE and find that it is about 56 pound, which is equal to 249 Newton. First we draw the parallelogram OA DB and then draw the diagonal OD, which is the resultant of OA and OB. Then using OD as a side, we draw a parallelogram ODEC. The diagonal OE is the resultant of the three forces and has a value of about 56 pound as previously stated. A force can be resolved into its component if certain facts are known. For example, the force OA is composed for force OB and OC, whose directions are known but whose values are unknown. To determine the value of force OB and OC, it is merely necessary to draw AC parallel to OB to the points where it intersects with OC and AB, parallel to OC to the point where it is intersects with OB. If OA is 30 pounds, that is 133.5 newtons, then we find that OC is about 24 pound or 107 Newton, and OB is about 17 pound. This determination of the components of a force and resolution of force. Here something mistaken. We say OA, OB directly. Some are OC dash, someone is OA dash, and this like that. AB dash. This determination of the components of a force is called resolution of forces. I don't want to name the book. Please go through it it will be much more convenient, and I find this book only to explain you in a better manner. Just I've given a lecture only. I've not given all the full things, and I'm not given any picture of it. No, only I will give you a conversion chart of metric and English system. If we could have gone for the forces acting and the resolution of forces, the vectors. This determination of the components of a force is called the resolution of forces. It must be noted that the combination of vector forces, that is forces having both the magnitude and direction, requires something more than the mere addition of quantities. Vectorial addition is accomplished by mean of parallelogram or triangles, on as demonstrated in the coming topic. This is important in the solution of a problem of alternating current, where we must combine electrical quantities having both magnitudes and phase angle.